for the 3D portion of this, I was thinking we could go through and put some toolpaths on this. I think there's some good areas on here for plenty of different toolpaths that we can take a look at. I'm going to go through and add some roughing to this real quick. So we see we have a big block here. So we'll just kind of get started. Certainly, Angelo, Jonathan, hop in, cut me off if you want to do something else or show something else. While we're going through this, I'm going to add an arrow roughing toolpath. So this, for me, is a toolpath that is using a bigger kind of face mill. So this is using a 2-inch face mill. And then for my passes here, the reason I've made this a template is because this isn't a traditional way that I'd use the adaptive. I have a pretty wide step over here with, I don't know, 70-80% of the width of the cutter, and then I'm taking a small step down. You can also notice my maximum step down and my fine step down, I match them here so that we don't get any sort of like resolution cuts, right? So it always looks at this first parameter first, and then it's going to look to step up by this amount. If you match those amounts, all it's going to do is take 200,000s, 400,000s, 600,000s, 800,000s, and go like that. If we had this value at 100, right, like this, it would go 200,000s deep, and then it'd go up to 100, cut whatever it can, and then it would go down to 400, and then cut at 300, and then go down to 600 and cut at 500. So just because I want to quickly kind of rough this out and get the shape, get near net, I'm going to do that. Hit OK. Turn flat area detection on. That's not going to hurt us. And we won't worry too much about the roughing here. Obviously, we're kind of focusing on the finishing, but I got something like this. Let me see if I can hit function 8. Stock in there when it's ready. And then function 7, we'll turn that toolpath off. So then on here, let's switch to a, I'm going to go to templates. I'm going to go to end mill roughing. I'm going to use this to kind of rust machine these areas. But then I'm also going to use that just to finish all these flats and get those out of the way. So I'm just going to hit flat and hit OK. That should get rid of all the flats on the part. And then we can focus on these kind of 3D areas and look at how we would machine these. Angelo, any first thoughts coming to mind here when you look at this?
Yeah, I like that. And I did have a question about the flat, doing all the roughing, and then the flat. And sometimes when you go in there, those vertical walls aren't done yet. The flat does have, you can tell it to stay away from the wall so you don't get a big engagement on those vertical walls. So maybe, Devin, if you want to show users where that is, where it leaves material walls. There's like a stock to leave, or trying to remember the exact wordage. Because those vertical walls aren't done yet, right?
Yeah, I think that's a different toolpath.
I just wrote a document on this. Yeah, that's right.
Steep and shallow has the wall clearance. Good call out though.
I thought it was in here though. I thought it was in here, no? Maybe it's Hypermill that does that.
Oh,
Hypermill has a flat also, yeah. No,
where is that?
Yeah, I thought it was on the passes tab of flat. Unless something's changed.
Optimize pocket, spiral, smoothing deviation, cut interior both ways.
Maybe I'm mistaken, but I thought.
I mean, you can do that by turning it on.
Stock to leave, yeah.
And
we'll just do it there. Because you guys agree, right? Because you don't want to go right to the wall if the wall's not done.
No, I definitely agree.
Yeah.
Yeah. And Richard's right. Yeah, you could do whatever. But
yeah,
hey, like I said, all the flat finishing on here, pretend. We're gonna focus on the 3D stuff here. What kind of toolpath, Angelo, you think you would do on this part? This little. We've got a 3-axis machine. So these are probably flat, but
flat? Are they flat in those fillets?
I think these are flat, but yeah, let's look at maybe this whole area here.
Like parallel would be super easy to do.
Mm-hmm.
Then you're not
parallel for sure.
ISO curves, yeah.
Let's take a look at that.
Curves, yeah.
Let's go in here.
Start simple.
Parallel.
Possibly even a blend.
Oh, I think you get morph there, Jonathan.
Morph is another one I would try.
Morph would work for this. because it's relatively low slope.
Yeah.
Morph doesn't work very good when you need
Steeper. Right? It's
when
like
you need contact point boundary, because contact point boundary doesn't get added past morph. But I think we find a spot for that. We could probably show on the end here where morph wouldn't be great. But if we go to parallel here, how would we do this? So here's the one thing I would always suggest, especially when you're getting into 3D toolpaths. Don't go super crazy. I mean, and it obviously depends on the part, but let's just set our step over here to like 100 thousandths. Change the tolerance too if you got something super big, you're doing a bumper mold or whatever. 100 thousandths, and let's just hit OK. Let's just see what it does. Okay. Stripes across the part, and what are some things we want to do? I want to focus it. Let me turn the stock off because that makes it kind of messy. I want to focus it on just this area right here. So there's a couple different ways to do that. We could add a surface boundary here by clicking this outside edge and telling it just to stay in that area. That's the preferred method that I would do. So I would start here on the geometry, go to selection. I would click right here, and then I'm going to click that again, and I'm going to try to get it to go within this region, and it can be a little tricky there. So what you can do then is
there you go. Beautiful.
Switch it from closed chain because it didn't want to do it back to open chain, and it can't be an open chain, and hit OK. And now we have that area there. Is that what we wanted? No, we want to add the thing. Let me turn this eyeball off. We want to go up here. Oh, that is difficult, huh? So let's do this. Jonathan.
Because of fillets, yeah.
Yeah, do a surface.
Face contour.
Need your face, yeah, there you go.
Boom.
So this will build that up
Yeah,
too as kind of an alternative option. And we want to have contact point boundary turned on. Let's tighten this up a little bit. We'll go 20 thousandths and hit OK. And we get something like this.
Yeah. All those little.
So we get a little bit of noise here, right?
Squeeze.
I taught you guys a couple weeks ago how to finish this noise. Get this tolerance right here. We can go here and we can say negative tol, or if you're an ape like me, I'm just going to type in -4 tenths. And there we go. Thoughts on this, boys?
Yeah, not ideal on the fillet side. On the flats, it's good on the flats.
Flat side is good because it matches up here. On the fillet side here, what will we have? We'd have probably a lot of little cusps here where it's starting and stopping and moving over. So what we could do, notice here how parallel, this is a very shallow surface here, but parallel has to actually come off the edge here to finish this. So the next one, the one that Angelo said, which would work good for this, but it's going to leave a little bit of a cusp here because we have to have the tool go that far, would be morph. So if we come in here and choose morph, let's do this. I'm going to hold Alt. I'm going to click on that, and I'm going to edit it, and we'll add that edge there. Morph is looking for two of these edges to kind of blend to, and it blends exactly between whatever contours we pick. So I don't know why I didn't grab the end here. Looks like those are just little segments. Okay, so we got that. And you know what's weird, Angelo?
Yeah.
I can't see the direction of these.
Oh, it didn't highlight it. It didn't highlight it.
It shows it here. It shows it when you edit it, but it used to show it here. So I want to show you a problem that you'll get. Watch. If I reverse this direction here on this one, I know this is wrong. So our chain here on the left has the arrow going that way. I can show you that right here. And our chain here has the arrow going this way. When we hit OK on this, we're going to get kind of a weird hourglass.
Yeah, like a bow tie looking thing. Yeah, hourglass is a good one. Yeah,
right?
Yep.
And some might think, well, it's broken or we picked the wrong thing. Well, we picked the right thing. It's actually just the one contour is backwards. So obviously I forced it to do that. So we can come in here and say, don't reverse it, hit OK, and then hit accept. And then we'll get the toolpath to go that way. Now, how does that look, Angela? A little bit better?
That looks better than parallel, yeah.
It looks better than parallel. It is going off the edge here, which that's new behavior. Oh, it's not. So it's not new behavior. Look at it from the top. From the top here, what does it do?
All right.
It
Yeah.
just blends between the two chains. So
Oh, yeah.
it does have partial toolpath creation in here because this other segment is longer. But if we turn on contact point boundary, which obviously we have to get this front part, which keeps zooming out, we have to get that front part to come in here. It kind of ignores that. It doesn't actually respect it at all because it is just taking this back line and this line and just morphing a toolpath in between them. It doesn't really care for the surface or for whatever boundary we have picked here.
Right. Right.
We didn't pick a boundary, so we would have to kind of do the same thing, try to trim it.
It's a great example to show the people on the call of different things to consider when you're choosing a toolpath and some of the down or pitfalls of certain toolpaths and some of the behaviors.
So again, not a great toolpath. You see here how they're like the front. You'd have a little ridge right here if we were to simulate this. Because look at the parallel. You see how the parallel has that one little area? There's a little region here where the parallel is extended. That's kind of what we would have been looking for this. Obviously, super little, super minute here. Another one that would be great, probably easy to do, would be flow. If all of these match up or this makes a nice toolpath, we can just hit on there, tell it what step over we want, and hit OK. It should do that almost right away here.
Yeah.
The pattern goes the other way, so we can try to reverse it, so we can get it to blend together. Say a long V. Now, depending on the orientation here, we may get two toolpaths, which is what we did. We got two different toolpaths here. So it took this group of surfaces, kind of made it into its own toolpath, took this group of surfaces, kind of made it into its own toolpath. So it's using the isometric directions here on the surfaces to get these. So again, even though this is better, this would probably work. This would get us to where we need. Not what I would do. I would probably have went with either a blend or a geodesic. So with blend, we can come in here and just pick these surfaces, and we can try to do it without changing anything. So we can go ahead and hit OK. We're going to ignore not having any drive curves. I want to see if it can figure it out on its own. Which it should be able to. Computers sounds like a Dyson fan.
Yeah, some good geometry to kind of highlight different toolpaths and then the behaviors. So it's a good picking this part, Devin.
So we got a couple warnings here. Now, a warning doesn't mean that the toolpath is bad. It just means that it altered something or it's trying to tell us something while the toolpath was created. It still created a toolpath, but it's just saying there was no drive curve selected to machine, so it figured them out on its own. This is kind of a newer thing as of like a year ago that it could do. Now look at that. I would say that's pretty good. We have one lead on. We have a really smooth start. We have a blending or a morphing toolpath between those two edges we picked. And we have little step overs on the end. It's getting us exactly what we need to cover the surface. So you can see here we got that little bit we were looking for. So unlike morph, where morph kind of misses that area. And obviously this is a very low slope, guys. The more the slope gets steep, the worse this problem is going to be with a morph toolpath. Because blend sees the surface, it knows exactly where it can put the tool on the surface and where it needs to go to finish it. So the steeper the angle here, the more severe that case would be. So blend works really good. Blend would probably be my number one. The only other thing I would check, especially when I'm doing something like this, we may want to omit this flat section here, certainly. But then I would probably do these sections by themselves and then do the fillet altogether because we've already kind of machined this flat with the flat toolpath here. One thing that is nice though, if we are going to do this and we don't want that section to be machined, we can click on this with the extension. We can come in here and we can just go. Let's get rid of those bad boys. Now on our flat toolpath, those are going to be omitted. and then we can fully machine it with this toolpath here. So I would probably also try geodesic. Geodesic is probably going to give us the same result here, if you know the right settings. So if we come in here and hit OK and set this maximum step over to 20 thousandths, we're going to hit OK. The toolpath will not look the same though. Let's do it again while we're waiting for that one. Geodesic. And I guess it calculated fast enough, but you can see the blend looks very, very nice. Geodesic gives us something like this. Why does it do that, Angelo?
Scallop. Wait, we
Scallop.
scallop or blend?
It's because of the type
Scallop is
that
default.
it is, right? So
Yeah.
it's collapsing in the boundary, right? These collapses are generally not good, especially when we get sharp direction changes here. We're going to see that. That's going to result in a differing tool pressure. If you have, let's say this tweezers is my tool here. If you're cutting and you're supplying constant pressure to the tool like this, and then you snap the tool the other way and change the direction, the pressure is not going to stay consistent on the tool, right? So every time you change direction, your tool is kind of doing this a little bit. That's why you're going to get those marks on your part.
Yeah.
So we want to be very smooth and steady with our direction here. So
yeah, we call that coining. Coining, like if you take a coin and you press it in sand or something. So, and then also there's the offset passes using, but you're going to get to that later. You would think that the obvious would be blend. Sometimes it doesn't give you the result.
The obvious would be blend. Yeah. So here we have a blend result and we have a geodesic result. They both look pretty good. One is a few minutes longer. So this is the other thing I do to architect my toolpaths when I'm looking at these guys, especially in 3D. If you don't see these machining times, go to your preferences and you're going to go to manufacture and you're going to turn all these options on. There's a show cycle or show just machining time. But I just turn them all on because it'll give you the most information there. That way your fusion will look like mine. I think geodesic is probably slower because of all these big lead in and lead outs on the ends.
Yeah, part of it. Mostly.
And the feed rate would be different, probably, perhaps. Like
feed
a vertical.
Probably the same. I think it's the same
like
tool.
A punch feed rate? Yeah. Okay. Yeah.
It looks like there's more segments as well on that upper fillet. Like when you jump from one to the other.
We can check that. I'm gonna try to get these equalized out, right? So I took those all off and I was wrong. We got 22.5 minutes and still 25.5 minutes. We can double check and take a look at the points here. This is the geodesic. Now there's no smoothing turned on. This is the blend. I would say pretty similar. I mean, these are fairly flat shapes. So, I mean, I guess we don't necessarily need all those points in there. But here you can see we get some differing points on there. So I don't think any of this we're really going to see on the machine. But yeah, why is that time different? Let's see. What does this one say? Yep, same cycle time. So the step over here, this is the maximum step over also. So it's like probably the distance in between here, where if you look up here, you'll see it's doing the same number of passes everywhere, but this is a shorter area. So these are a lot closer together here in this region.
I like the one entry and one exit.
Yeah, both of these produce a good result.
Yeah, they do. Yeah. Less noisy, like you used that word earlier.
And then either blend or geodesic for this section here, especially with if I want to include these fillets. Because this is a similar type of surface here. Blend and or blend in geodesic here need two things, right? They need two edge profiles, kind of like what we selected in morph. So two open profiles to kind of morph to and from, or two closed profiles like what we have here. So if I just choose blend here, I hope this can get it by itself. So One of the things you have to usually pick all the surfaces and then pick those drive curves. So those sets of curves that are going to blend together. That's a horrible picture for that.
Yeah.
That thing there.
Terrible tooltip. Yeah.
Because that tooltip, that would not work if you picked that. If you picked headlights and the windshield and whatnot, they're not connected. So I'm gonna hit OK. It's gonna warn me to say I don't have that. You can say, yeah, I want to ignore the warnings, and I want to see if this can work by itself. The only thing I would be concerned with is maybe this section right here.
I was just gonna say that little sliver.
The little flat there. Is that flat? That was flat, right?
It is
handled
flat,
in
yeah.
flat. It is flat, yeah. Those engineers.
Those pretengineers.
That's a funny term. Excuse me.
Yeah, even though I never was an engineer, I don't know why I felt more of an engineer than most of the engineers that I worked with.
When I meet people and I talk to them, they say, what do you do? I just say engineer, because if I say machinist, they'll be, oh, you are a mechanic or you work on machines.
I don't even get that. If I just tell them I cut parts out of metal.
Yeah, that's
usually they just give you a head nod and go, well, there you go.
Yeah. Yeah, it's hard to describe a machinist to some folks.
Yeah. I agree. I've had that struggle for about 20 years.
Yeah, mine's since 88. I've had that same struggle. It's the struggle is real, I guess. When you get down to the final 2 picks.
88. So you were machining parts when I was 2 years old.
Yes, sir. Yep. That's why I don't have any hair up here. I lost it all going crazy trying to troubleshoot stuff. I've had a boatload of headaches over the years. But the crew has been really good to me. I've had a lot of fun.
So I would say that looks pretty nice.
Yeah, that's
one
nice.
lead on, one lead off. If you want to see the rest of this video and more like it, be sure to join us at the Digital Manufacturing Collective. The link is in the description below. I'll see you over there.